Welcome to This Explainer. Today, we're tackling a scenario that literally keeps developers up at night, the mystery of slow database queries. We're going to use the classic Sequila sample database to learn exactly how to methodically investigate and fix these issues right inside MySQL Workbench. If you've ever felt that utter frustration of watching your entire system grind to a halt because of one single data request, you are definitely in the right place.
So let's dive right in. We've all been at this exact crime scene. You write a query, you test it locally, and it runs almost instantly, like 0.1 seconds. Feels great, right? But the second that exact same code gets pushed to production, the query takes 30 seconds, or worse, completely times out. The difference, of course, is scale. Your dev database might have a few hundred rows, while production is housing millions. And when data scales, missing optimizations don't just slow things down, they break the system entirely. Section 1. Decoding the explain command, your investigative magnifying glass.
To figure out why a query is dragging, we just drop the word explain right in front of it. Now, MySQL won't actually run the query. Instead, it asks the query optimizer to reveal its execution plan. Basically, the exact strategy it plans to use to get your data. Looking at this tabular format, we really need to focus on three specific columns: type, key, and rows. Type tells us the access method, key tells us which index is actually being used, and rows is the database's estimate of how many records it has to scan to find the result. And notice here, the key is completely null.
And that leads us to a massive red flag. If you see the word all in that type column, that is your smoking gun. It represents a full table scan. That means the database is painfully reading every single row from the disk because it couldn't find a suitable index. In modern, high-scale environments, this is still the #1 cause of database-induced latency. Even with lightning-fast storage, the CPU overhead of processing millions of rows sequentially is just going to bottleneck your whole system.
Section 2. Reading visual explain diagrams, seeing the bottleneck. Now, if parsing raw text tables isn't really your thing, MySQL Workbench actually translates this into a super intuitive, color-coded flowchart called Visual Explain. Working here with the standard Sequila sample database, the most terrifying thing you can spot is a bright red node. That red color is absolutely intentional. It screams that a highly expensive operation is happening. It's basically the visual equivalent of that all access type we just talked about. When you see red, you instantly know where your query is burning server resources. Hover over that red node, and you'll see the rows examined metric. And here we see the sheer scale of the problem, 1.5 million. The system is grinding through 1.5 million records sequentially just to find a handful of matching results. It's literally like reading an entire phone book from cover to cover just to find one person's number.
Section 3. Case study, slow support query. A methodical DBI investigation.
Okay, let's look at a real-world scenario. A support engineer gets a frantic ticket, a payment report query on a massive production database is timing out and taking the whole application down with it. We're going to follow the calm, methodical workflow of a senior DBA to fix this. Step 1, identify the slow query using application logs. Step 2, run explain on that exact query in MySQL Workbench. Step 3, locate the bottlenecks by checking the type and rows columns. And Step 4, surgically apply a fix. No guessing, just data-driven optimization.
So, following that workflow, our engineer runs the explain command for this sluggish report, and they instantly spot the problem. The query is filtering the dataset by a column called transaction date. But if you look at the key column, it's completely empty. It just says null. And the type column screams all. So this confirms absolutely no index is being used. The database is reading every single payment record ever made just to find transactions for one specific date. The fix here is totally surgical. We aren't rewriting the whole application, we're just giving the database a map. We run a simple command, create index IDX_date on payments for that transaction date column. This creates a B tree index, which is your default everyday index type. Think of it like a quick reference catalog at the back of a book. Instead of scanning every single page, the database engine can now just jump exactly to the dates it needs. All right, so the new index is live on our production table. Now for the moment of truth. What happens to our application's performance? Let's rerun that exact same report query and look at the actual execution time. The execution time absolutely plummets. We go from an agonizing 28 seconds, which, remember, was causing timeouts and angry users,
down to a lightning-fast 0.3 seconds. That is the sheer power of a single, well-placed index. We didn't upgrade any server hardware. We simply allowed the database optimizer to do its job efficiently.
And this perfectly illustrates what happened behind the scenes. Looking at Visual Explain again in MySQL Workbench, the difference is night and day. That terrifying red node on the left, the one representing our full table scan of 1.5 million rows, completely gone. It's transformed into a calm, blue node on the right labeled Index Range Scan. Instead of reading over 1 million rows, the database effortlessly scanned just 15 rows using our new index. The CPU and disk bottleneck totally eliminated.
So let's wrap up with the key takeaways you can start using today. First, always check your query execution plans using Explain. Never assume you know how the database is getting your data. Second, actively hunt down those full table scans by looking for type all. Third, utilize Visual Explain in MySQL Workbench to quickly and intuitively diagnose those bottlenecks. And finally, strategically add indexes to the columns you frequently use in your where and join clauses. I'm going to leave you with this final thought to investigate on your own systems today. As your datasets grow exponentially day by day, which silent, unindexed queries are currently hiding in your application code, just waiting for the data volume to get large enough to take down your production environment? Grab MySQL Workbench, run an explain on your heaviest queries, and find out before your users do.